Okay, the point of this video is to clarify the EOQ shortcut to total annual costs, which in short is 2 times annual demand times setup cost times holding cost and the square root of that. But the key thing is this is what I call the EOQ shortcut, economic order quantity shortcut, which in plain English means you can only use this at Q asterisk, which is that economic order quantity. That's very important. You can't just use this at any other time. Because when we talk about what is EOQ, we're talking about if this is order quantity, and this is those total annual costs. Again, EOQ is the point at which we balance out holding costs and ordering cost. So if we order a few items and then we order a lot, that curve looks like this. If we order a few items, we have low holding costs, but then the more and more that we order, that curve looks like this. So this is holding cost. This is ordering cost. EOQ is that point at which they equal each other. Okay, and this quantity here refers to this quantity here. And it is only at this point that we can use this formula. So on this next screen, I'll show you why that is so. Ordering or setup costs and holding costs. And we were talking about this point here is Q asterisk. And this is the point at which holding costs and ordering costs are equal. If we go out here, and so we can sum these two curves, this curve plus that curve. So if we add this plus this, we have a total point here. And if we add this plus this, we have probably a total point here. And if we add these two, total costs we have is about here. If we add these two, it starts to go back up again. So we kind of have this shape for total costs. It looks something like that. So if we go out here, for example, we would not only have a higher total costs, but the holding costs would be much higher than the ordering costs. And this would just be a Q. Conversely, if we go over here and go up to this total cost point, we would have holding costs much lower than ordering costs. And this is another point Q. We could just call this Q1, Q2. It doesn't really matter. They're not this point, which is Q asterisk, which is EOQ. Now, formula-wise, we know that total cost, total annual cost, is equal to demand quantity times setup cost plus quantity times, or divided by 2 times holding cost. So at any point along this range, that's what the total costs equal. At Q asterisk or EOQ, these two become equal. Okay? Then again, to back up just a step, this right here is equal to our annual setup or ordering costs. And then this right here is equal to our annual holding costs. So at this point here, the EOQ, they are equal to each other. Well, what is the significance of that? Well, if we take this and substitute it for that at the point of EOQ, which we can do because these are equal, our total cost equation looks like Q over 2 times H plus Q over 2 times H. And that is equal to 2 times Q over 2 times H. Those cancel with each other, so we have Q times H. So then we have total cost equals Q times H. So what? Well, what we're trying to do is get this Q out of the equation. So let's just put in the formula for Q. So we would need to put in a formula for Q asterisk. So at this point, we'll have our total cost equals, remember the formula for Q asterisk is 2 times ds over H. Now, with anything times itself, let me just go to another screen and we'll continue right down here with this. So, again, with EOQ only, we can work so that we have times H. Okay. So let's just go over here for a second and have a thought. So if we were to have X times X, right now I'm thinking about these H's, what we do with those. If we have this formula, we know that the square root of X times the square root of X is X. Therefore, the square root of X equals X divided by the square root of X. Or, put another way, the square root of X equals X over 1 times 1 over the square root of X. Important to clarify that this extends all the way down. Okay? So, essentially what we have will be with this equation, x over 1 is like saying h over 1 times 1 over the square root of x times 1 over the square root of h. And so all this right here, that there, and this here is why we can say that total cost equals the square root of 2 times ds, but then this all equals h under the square root as well. Hence, the origin and justification for our EOQ shortcut. And that's a rather long way of saying this formula does equal total cost, but only at the EOQ. If we go somewhere else, along that range, in fact, if we go anywhere else other than the EOQ, we cannot use that formula because these don't equal each other. It is only at this point here, the EOQ, that we can use that formula. Can't stress that enough. Or that shortcut. So, that's the justification for what I call the EOQ shortcut.